We can use virtual machines to run old applications which was on old operating systems. We can use it to share resources with innumerable number of people in our organization or outside our organization. We can install multiple virtual machines, each having its own operating system. How is it useful? I have developed software on one platform, I want to test it on another platform, or I have developed that software, it's only meant for one small client of mine. So instead of buying a separate computer and separate software and all that, with my existing resources only I have developed it. I just want to test it, and I want that to be tested by different teams. So for instead of buying the different computers for different teams, I can create virtual machines and load that application, and I can ask them to test and document. So idu ಮಾಡಬಹುದು. Now, so this is a virtual machine. What is this virtual machine VMware? It is a software. It is a software which helps to give a false belief of an independent hardware. There is an independent hardware and a false belief code. This is actually a software which is running. So I was giving in the morning, okay, one example. Okay. So each of this, it is having, okay, this VMware, this is a computer on a computer. We are getting a belief there is a computer on a computer. And not only one computer, you can have, for example, in this VMware workstation, you can have around some 32 machines, 32 VM machines you can have. But ಅವೆಲ್ಲದಕ್ಕೂ RAM ಎಲ್ಲ ಜಾಸ್ತಿ ಬೇಕಾಗುತ್ತೆ. Okay. Now if you are having a laptop with minimum 8 GB of RAM, you can run say 2 operating systems on it. ಒಂದೊಂದಕ್ಕೂ 4 GB ಕೊಟ್ಟು ಅಥವಾ 3 GB ಅಥವಾ 2 GB ಈ ಥರದನ್ನು ಕೊಟ್ಟು ಲೆಸ್ ದ್ಯಾನ್ 8 GB ಆಫ್ ರ್ಯಾಮ್ ಇರೋ ತನಕ ಆಪರೇಟಿಂಗ್ ಸಿಸ್ಟಮ್ಗಳನ್ನ ರನ್ ಮಾಡ್ಕೋಬೋದು ಇನ್ ಯುವರ್ ವರ್ಚುವಲ್ ಮೆಷಿನ್. ಸೈಮಲ್ಟೇನಿಯಸ್ಲಿ ಎರಡು ಓಪನ್ ಮಾಡಿಬಿಟ್ಟ ಅಂದರೆ ಯುವರ್ ಮೆಷಿನ್ ವಿಲ್ ಬಿಕಮ್ ಸ್ಲೋ. Your machine will become very slow. So I will show you the things here. So illi the very first one, I hope you are able to see this. I have installed a Windows XP Professional, which was a old operating system. I am having Windows 10 on this. I have loaded a Windows VMware workstation 64-bit. ಇನ್ಸ್ಟಾಲ್ ಮಾಡಿದ್ಮೇಲೆ ಅಲ್ಲಿ ಒಳಗಡೆ ಹೋಗಿ ಐ ಹ್ಯಾವ್ ಟು ಕ್ರಿಯೇಟ್ ಸಮಥಿಂಗ್ ಕಾಲ್ಡ್ ಕ್ರಿಯೇಟ್ ಎ ನ್ಯೂ ವರ್ಚುವಲ್ ಮೆಷಿನ್ ಅಂತ ಹೇಳಿ. ಸೊ ವೇರ್ ಎವರ್ ಐ ಹ್ಯಾವ್ ದಟ್ CD ಆಫ್ ವಿಂಡೋಸ್ XP ಆರ್ ಲೈನಕ್ಸ್ ಆರ್ ಸಮಥಿಂಗ್, ಐ ಕ್ಯಾನ್ ಬ್ರಿಂಗ್ ಇಟ್ ಆ್ಯಂಡ್ ಐ ಕ್ಯಾನ್ ಲೋಡ್ ಇಟ್ ಅಷ್ಟೇ. ಇಟ್ಸ್ ವೆರಿ ಸಿಂಪಲ್. ಇನ್ಸ್ಟಾಲೇಷನ್ ಈಸ್ ವೆರಿ ಸಿಂಪಲ್. ಈಗ ಕ್ರಿಯೇಟ್ ಮಾಡಿದ್ದೀನಿ. ಪ್ರತಿಯೊಂದು ಆಪರೇಟಿಂಗ್ ಸಿಸ್ಟಮು ಹ್ಯಾಸ್ ಗಾಟ್ ಸಮ್ ರಿಕ್ವೈರ್ಮೆಂಟ್ಸ್ ಫಾರ್ ಹಾರ್ಡ್ ಡಿಸ್ಕ್, ಸಮ್ ರಿಕ್ವೈರ್ಮೆಂಟ್ ಫಾರ್ RAM, ಸಮ್ ರಿಕ್ವೈರ್ಮೆಂಟ್ ಫಾರ್ CPU. Okay, VMware workstation is intelligently designed to allocate those resources, but you can also go and configure it yourself. ಈಗ Windows XP Professional ಗೆ ತೋರಿಸ್ತೀನಿ. ಇಲ್ಲಿ it has selected a 512 MB RAM. Minimum it requires 512 MB RAM to run Windows XP operating system. I can double click on this and I can still change. I can shift through. I am having some 4 GB of RAM. If I can spare 1 GB, I can send it. Okay, so here we can make the changes for the resources. For what all things we can make changes? We can make changes for the RAM, we can make changes for the CPU, whether you want to give single CPU or dual CPU. You want to give a hard disk, minimum hard disk it requires 40 GB. ಈ 40 GB ಎಲ್ಲಿಂದ ತಗೊಳುತ್ತೆ? ನನ್ನ ಹತ್ರ 500 GB ಹಾರ್ಡ್ ಡಿಸ್ಕ್ ಇದೆ. ಐ ಆಮ್ ಹ್ಯಾವಿಂಗ್ ಎ 500 GB ಹಾರ್ಡ್ ಡಿಸ್ಕ್. ಆ 500 GB ಹಾರ್ಡ್ ಡಿಸ್ಕಲ್ಲಿ 40 GB it goes and creates a territory for itself. I can't copy any other thing to that. That is used exclusively for this Windows XP virtual machine. Although I will show you how it is shown. So this is the path where I have saved. So ಅದೇ ಥರ CD-ROM drive, if you want, you can enable it, you can disable it. Okay. ನಂದು ವಿಂಡೋಸ್ ಎಕ್ಸ್ಪ್ಲೋರರ್ ಕಾಣುತ್ತಾ ನಿಮಗೆ? ಆರ್ ಯು ಏಬಲ್ ಟು ಸಿ ಮೈ ವಿಂಡೋಸ್ ಎಕ್ಸ್ಪ್ಲೋರರ್? Kiran is not able to hear my voice. Okay, are you able to see my Windows Explorer? ಇಲ್ಲಿ ವಿಂಡೋಸ್ ಎಕ್ಸ್ಪ್ಲೋರರಲ್ಲಿ ಜಸ್ಟ್ ಟೇಕ್ ಎ ಲುಕ್ ಎಟ್ ಇಟ್. ನಾನು ಏನೇನು ಇನ್ಸ್ಟಾಲ್ ಮಾಡಿರ್ತೀನಿ, ಇಟ್ ಈಸ್ ಆಲ್ ಲೋಡೆಡ್ ಇನ್ ಮೈ ಸಿಸ್ಟಮ್ ಸಮ್ವೇರ್. ಓಕೆ, ಸಿ ಡ್ರೈವಲ್ಲೋ ಎಲ್ಲ ಸ್ಟೋರ್ ಮಾಡ್ಕೊಂಡಿರುತ್ತೆ. ಸೊ ಫಾರ್ ಈಚ್ ಆಫ್ ದಿಸ್ ಈಸ್ this contains the virtual machine which I have installed in my VMware. Windows XP install ಮಾಡಿದ್ದೀನಿ, ಉಬುಂಟು ಮಾಡಿದ್ದೀನಿ, ರೆಡ್ ಹ್ಯಾಟ್ ಮಾಡಿದ್ದೀನಿ, ವಿಂಡೋಸ್ XP ಪ್ರೊಫೆಷನಲ್ ಮತ್ತೊಂದು ಹಾಕಿದ್ದೀನಿ ನ್ಯಾಷನಲ್ ಕಾಲೇಜ್ಗೆ. ದೆನ್ CentOS ಲಿನಕ್ಸ್ ಕೂಡ ಹಾಕಿದ್ದೀನಿ. ವಿಶ್ವ ಕಿರಣ್ ಪ್ರೆಸೆಂಟ್ ಸರ್, ದಟ್ಸ್ ಓಕೆ, ಫೈನ್. ಹಾಂ ಹೇಳಿ, ಯಾ ಫೈನ್, ಐ ವಿಲ್ ಟೇಕ್ ಇಟ್. ಓಕೆ, ಇದು ನಂದು ಕಾಣಿಸ್ತಾ ಇದ್ದಲ್ಲ ವಿಂಡೋಸ್ ಎಕ್ಸ್ಪ್ಲೋರರ್. ಯು ಆರ್ ಏಬಲ್ ಟು ಸಿ ಮೈ ಸ್ಕ್ರೀನ್ನ? Are you all able to see my Windows Explorer? Okay, fine. So ಇದು ನೋಡಿ, when I go inside this, ಇದರಲ್ಲೆಲ್ಲ ಯಾವ್ಯಾವ ಟೈಮಲ್ಲಿ ಲಾಗ್ ಆಗಿದೆ, ಆಲ್ ದಟ್ ಇನ್ಫಾರ್ಮೇಷನ್ is all available. Like it has installed a Windows operating system within that VMware, and it has allocated this much amount of space. ನೋಡಿ, it is taken some 2 GB ತಗೊಂಡಿದೆ ಇದರಲ್ಲಿ. ಇಲ್ಲಿ ನೋಡ್ತೀನಿ, ಇದರಲ್ಲಿ ಒಂದು 2 GB ತಗೊಂಡಿದೆ. ಅದೇ ಥರ ನಾನು ಬೇರೆ ಅದಕ್ಕೆಲ್ಲ CentOS ಅದೆಲ್ಲ ಹಾಕಿದ್ದೀನಿ. ಒಟ್ಟು 20 GB ಫ್ರಮ್ ಮೈ 500 GB ಹಾರ್ಡ್ ಡಿಸ್ಕ್. ಇಟ್ ಹ್ಯಾಸ್ ಟೇಕನ್ ಅಬೌಟ್ 20 GB ಆಫ್ ಹಾರ್ಡ್ ಡಿಸ್ಕ್ ಟುಗೆದರ್. ಓಕೆ, ಸೊ ಪ್ರತಿಯೊಂದೂ ವಿ ಕ್ಯಾನ್ ಗೋ ಆ್ಯಂಡ್ configure it. What type of a network device is it? Is it a LAN either ಅಥವಾ direct ಆಗಿ is it connected to internet? Virtual machine also I can connect it to internet. Through virtual machine I can connect through internet if my machine is enabled. Okay, each of this virtual machine each of this virtual machine will have a physical identity. When you go to ping and when you try to find out IP config of your machine, ಎಷ್ಟು ವರ್ಚುವಲ್ ಮಿಷಿನ್ಸ್ ನೀವು ಇನ್ಸ್ಟಾಲ್ ಮಾಡ್ಕೊಂಡಿರ್ತೀರಾ, ಪ್ರತಿಯೊಂದು ವರ್ಚುವಲ್ ಮಿಷಿನ್ಗೂ ಒಂದೊಂದು ID ಕೊಟ್ಟಿದೆ. ಓಕೆ, ಸೊ ದಿಸ್ ಈಸ್ ಲೈಕ್ ಎ ಮೆಷಿನ್ ಇನ್ಸೈಡ್ ಎ ಮೆಷಿನ್ ಅಷ್ಟೇ. ಓಕೆ, but this is not the true machine. This is called as a abstract machine. Abstracted are a sort of a logically made machine. Abstraction painting ಅಂತ ಇರುತ್ತಲ್ಲ, modern painting, modern art, ಆ ಥರ this is an abstracted machine. So ಇಲ್ಲಿ ಇನ್ಸ್ಟಾಲ್ ಮಾಡಿಕೊಂಡು you can run these applications. Okay, and on those operating systems you can install your app, you can do testing, training. ಎಷ್ಟೊಂದು ಸಾಫ್ಟ್ವೇರ್ಗಳು ಕಲಿಬೇಕಾಗಿರುತ್ತೆ ನೀವು ಅಂದ್ಕೊಳ್ಳೋಣ. ಆವಾಗ if it is supposed to be available in some other operating system, you get it and you can learn it. So that is the advantage of Windows VMware workstation for personal applications. Okay, so then we will continue further. Tarun also not. Okay, so we'll go to the theory. I had sent you yesterday 2 PDF files, one on virtualization, another one on cloud computing. They are very good, very crisp. ಒಂದು 60 ಪೇಜು 80 ಪೇಜು ಹಂಗಿರುತ್ತೆ. ಅದು ಓದಿ ತಿಳ್ಕೊಂಬಿಡಿ till you get your some of you, I do not know whether you have got login ID. Still Dhanlakshmi, Ambika, still they have not got the login ID for the LMS. So you have to go through the material. So in addition to the material which I had sent you, this is good enough to know about virtualization as well as for cloud. Okay, we'll proceed further. So ನಾನು ನಿಮ್ಗೆ ಆ PDF ಕೊಟ್ಟಿರೋದು, you can read it in your mobile. If you have any other device to read, tablet, you can read from that, you can transfer it. If you want to transfer it to your laptop or desktop, that also you can do. Athwa you want to take printout of it, bound it, read it. It's a very useful document which you can use to learn and also to teach. From your last year's batch, somebody had asked me, sir, I am interested to teach now, join a teaching profession ಅಂತ. ಈ ಕ್ಲೌಡ್ ಕಂಪ್ಯೂಟಿಂಗ್ ಅಲ್ಲಿ ಟೀಚಿಂಗ್ ಮಾಡೋದು, ಟ್ರೈನಿಂಗ್ ಮಾಡೋದು, ಇಟ್ಸ್ ಎ ವೆರಿ ಗುಡ್ career. You can go and train in various engineering colleges. So I have given you certain material which will be useful to you. ನಾವು ಈಗ ವರ್ಚುವಲೈಸೇಷನ್ ಅಂತ ತೋರಿಸಿದೆ ಈಗ. ಓಕೆ, ಇನ್ VMware ಈ ವರ್ಚುವಲೈಸೇಷನ್ ಅಲ್ಲಿ ಮೇನ್ಲಿ ದೇರ್ ಆರ್ 2 types of virtualization called as a full virtualization and para virtualization ಅಂತ. ಫುಲ್ ವರ್ಚುವಲೈಸೇಷನ್ ಅಲ್ಲಿ ನಂದು ಫುಲ್ ಮೆಷಿನ್ ಇದೆ, ಅದ್ರ ಮೇಲೆ ನಾನು ಏನು ಆಪರೇಟಿಂಗ್ ಸಿಸ್ಟಮ್ ಹಾಕಲ್ಲ. ಐ ಇನ್ಸ್ಟಾಲ್ ದಿಸ್ ವರ್ಚುವಲ್ ಮೆಷಿನ್ ಡೈರೆಕ್ಟ್ಲಿ ಆನ್ ಮೈ ಬೇರ್ ಮೆಷಿನ್. On my bare machine which doesn't have an operating system, I install a virtual machine platform. On that virtual machine platform, I will create virtual boxes On those virtual boxes, I install operating systems and applications. ಅದಕ್ಕೆ full virtualization ಅಂತ ಕರಿತೀವಿ. Then there is a para virtualization. Para virtualization is what me and you do. In our laptop we have Windows operating system. ಅದರ ಮೇಲೆ VMware ಹಾಕೊಂಡು ಆ VMware ಮೇಲೆ ಮತ್ತೆ ಆಪರೇಟಿಂಗ್ ಸಿಸ್ಟಮ್ಗಳು ಹಾಕೊಂಡು ಮಾಡಿದ್ವಿ. ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಪ್ಯಾರಾ ವರ್ಚುವಲೈಸೇಷನ್. These are the two different virtualizations which are there. Okay. Virtualization refers to building an abstraction layer over the hardware. It resembles the underlying hardware, OS and other system components. Okay. It makes cloning the functionality of the original components of the software. Virtualization eliminates inflexibilities in hardware. ಏನಿದೆ ಹಾರ್ಡ್ವೇರಲ್ಲಿ ಇನ್ಫ್ಲೆಕ್ಸಿಬಿಲಿಟಿ? ಈಗ 10 ಜನ ಒಂದು ಆಫೀಸಲ್ಲಿದ್ದಾರೆ ಅಂದರೆ 10 ಕಂಪ್ಯೂಟರ್ಸ್ ತೊಗೋಬೇಕು. 100 ಜನ ಇದ್ದಾರೆ ಅಂದರೆ 100 ಕಂಪ್ಯೂಟರ್. 5,000 ಜನ ಇದ್ದಾರೆ ಅಂದರೆ 5,000 ಕಂಪ್ಯೂಟರ್ಸ್. At a time, not all 5,000 people will be using it. Some of the machines will be latent. They will not be working. Some of the machines are not working at all. Resource use ಮಾಡಿರಲ್ಲ. People will work in different shifts. ಡಿಫ್ರೆಂಟ್ ಶಿಫ್ಟ್ ಇಲ್ಲಿ ಕೆಲಸ ಮಾಡೋರು ಸೇಮ್ ಮೆಷಿನ್ ಯೂಸ್ ಮಾಡಬೇಕಂದ್ರೆ ದ ಪೀಪಲ್ ಮೇ ಅಬ್ಜೆಕ್ಟ್ ಆಲ್ಸೋ. ಸರ್ ನನ್ನ ಕಂಪ್ಯೂಟರ್ ಹಾಳು ಮಾಡಿಬಿಡ್ತಿದ್ದಾನೆ, ನನ್ನ ಕಾನ್ಫಿಡೆನ್ಷಿಯಲ್ ಇನ್ಫಾರ್ಮೇಷನ್ ಇದೆ ಕಂಪ್ಯೂಟ್ರಲ್ಲಿ, ಐ ಕಾಂಟ್ ಗಿವ್, ಈ ಥರದ್ದೆಲ್ಲ ಪ್ರಾಬ್ಲಮ್ಸ್ ಇರುತ್ತಲ್ಲ. ಸೊ ದೀಸ್ ಆರ್ ಆಲ್ ದ ಪ್ರಾಬ್ಲಮ್ಸ್ ವಿ ಫೇಸ್ ಇನ್ ಫಿಸಿಕಲ್ ಹಾರ್ಡ್ವೇರ್. ನೆಟ್ವರ್ಕ್ ಕನೆಕ್ಟಿವಿಟಿ ಮಾಡಬೇಕು. ಆ ನೆಟ್ವರ್ಕ್ ಕನೆಕ್ಟಿವಿಟಿಲಿ ಯಾವ್ದಾದ್ರು ಒಂದು ಕಾಂಪೋನೆಂಟ್ಸ್ ಫೇಲ್ ಆಗಿದ್ರೆ ಡೇಟಾ ಟ್ರಾನ್ಸ್ಮಿಷನ್ ಆಗಲ್ಲ, ಡೇಟಾ ಸೇವ್ ಆಗಲ್ಲ, ಡೇಟಾ ಪ್ರಿಂಟ್ ಆಗಲ್ಲ, ಈ ಥರದ್ದೆಲ್ಲ ಪ್ರಾಬ್ಲಮ್ಸ್ ಇರುತ್ತೆ. ದೆನ್ ಯು ನೀಡ್ ಲಾಟ್ ಆಫ್ ಪೀಪಲ್ ಟು ಟ್ರಬಲ್ ಶೂಟ್ ಯುವರ್ ಸಿಸ್ಟಮ್ಸ್. ದೆನ್ ವೆನ್ ದೇ ಆರ್ ಡೂಯಿಂಗ್ ಟ್ರಬಲ್ ಶೂಟಿಂಗ್, ದ ಮೆಷಿನ್ ಈಸ್ ಡೌನ್, sometimes the network may be down, sometimes the server may be down. ಸೊ ಎಲ್ರದ್ದು ಕೆಲಸ ವೇಸ್ಟ್ ಆಗುತ್ತೆ, ಕೆಲಸ ಮಾಡಬೇಕು, ಸುಮ್ಮನೆ ಕೂತಿರ್ತಾರೆ. ಸೊ ದೀಸ್ ಆರ್ ದ ಪ್ರಾಬ್ಲಮ್ಸ್ ವಿ ಫೇಸ್ ಇನ್ ದ ಫಿಸಿಕಲ್ ಇನ್ಫ್ರಾಸ್ಟ್ರಕ್ಚರ್. ವರ್ಚುವಲೈಸೇಷನಲ್ಲಿ ಈ ಎಲ್ಲದಕ್ಕೂ ಆನ್ಸರ್ಸ್ ಇದೆ. ಯು ಡೋಂಟ್ ಹ್ಯಾವ್ ಟು ಬೈ ಅಪ್ ಫ್ರಂಟ್ ಸೋ ಮೆನಿ ಮೆಷಿನ್ಸ್. ಯಾವ್ದಾದ್ರು ಹೈ ಎಂಡ್ ಕಾನ್ಫಿಗರ್ ಮೆಷಿನ್ಸ್ ತೊಗೊಂಡ್ಬಿಟ್ಟು ಅದರಲ್ಲಿ ವರ್ಚುವಲೈಸೇಷನ್ಸ್ ಕ್ರಿಯೇಟ್ ಮಾಡಿಬಿಟ್ಟು ಫಾರ್ ಆಲ್ ದಿ ಯೂಸರ್ಸ್, enable them to access it from anywhere with a login ID and a password. ಅವರು ಏನು ಅನ್ಕೋತಾರೆ, ದೇ ಲಾಗಿನ್ ಥ್ರೂ ಸಮ್ ಟರ್ಮಿನಲ್, ಡಮ್ ಟರ್ಮಿನಲ್ ಆರ್ ಥ್ರೂ ಮೊಬೈಲ್, ದೇ ವಿಲ್ ಲಾಗಿನ್. ದೇ ಥಿಂಕ್ ದೇ ಆರ್ ವರ್ಕಿಂಗ್ ಆನ್ ಎ ಸಪರೇಟ್ ಮೆಷಿನ್. ನಾವು ಹೈ ಎಂಡ್ ಕಾನ್ಫಿಗರ್ ಮೆಷಿನ್ ಇರೋದ್ರಿಂದ ಐ ಕ್ಯಾನ್ ಅಲೋಕೇಟ್ ಡಿಫರೆಂಟ್ ಅಮೌಂಟ್ ಆಫ್ ರ್ಯಾಮ್, hard disk to all the users. Centrally I can do it, and centrally I can do this configuration in a very short time compared to physical configurations. Physical ಆಗಿ machines configure ಮಾಡಬೇಕು, physical ಆಗಿ operating systems load ಮಾಡಬೇಕು, many other softwares to be installed physically. It takes more time compared to what you do in virtualization environment. ಅಸೆಟ್ ಮ್ಯಾನೇಜ್ಮೆಂಟ್ ಇರ್ಬೋದು, ಟ್ರ್ಯಾಕಿಂಗ್ ಇರ್ಬೋದು, ಸೆಕ್ಯೂರಿಟಿ ಕಂಪ್ಲೈನ್ಸ್ ಇರ್ಬೋದು, ಪ್ರಾವಿಷನಿಂಗ್ ಅದರ್ ಕಂಪ್ಯೂಟಿಂಗ್ ಡಿವೈಸಸ್ ಸಚ್ ಆಸ್ ಸ್ಟೋರೇಜು, ಯೂಸರ್ಸು, ಹಾರ್ಡ್ವೇರು, ಸಿ ಪಿ ಯು, ರ್ಯಾಮು, ಇದೆಲ್ಲನೂ ಇಟ್ಸ್ ವೆರಿ ಈಸಿ ಬಿಕಾಸ್ ಯು ಸಾ ದಟ್ VMware ಅಲ್ಲಿ ಹೋಗ್ಬಿಟ್ಟು ಜಸ್ಟ್ ಯು ಕ್ಯಾನ್ ಡೂ ಕ್ಲಿಕ್ ಆ್ಯಂಡ್ ಯು ಕ್ಯಾನ್ ಕಾನ್ಫಿಗರ್ ಹೌ ಮಚ್ much RAM he should be allowed to use for his operating system, how much storage he has to use it for his application, whether it is accessed by one team or there is a collaboration between multiple teams. ಪ್ರತಿಯೊಂದನ್ನು ಈಸಿಯಾಗಿ ಮಾಡ್ಬೋದು. ಸ್ಟಾಫು ಬೇಕಿಲ್ಲ, ಸೈಜಿಂಗ್ ಮಾಡೋದು ಕಷ್ಟ ಇಲ್ಲ. ಓಕೆ, I can't hear your voice, Tarun Mahesh. Sir, can't hear anything. How about now? Can you hear us? Can you hear from me? ನೆಟ್ವರ್ಕ್ ಹೆಂಗಿದೆ ಕೇಳ್ತಾ? IBM had conducted some survey over a period of time. ಒಂದು 2-3 ತಿಂಗಳು ಆದಮೇಲೆ they had conducted survey. So when it came to utilization of hardware and resources, they found that in virtualization nearly 60 to 70% of the resources are used, whereas in physical infrastructure 0 to 20%, 20% only is used. ಯಾಕೆಂದರೆ ಎಲ್ಲ ಪರ್ಚೇಸ್ ಮಾಡಿರ್ತಾರೆ, they will not be using it. So when they are not using it, you can bring them to what is called as a common pool. So there are certain services or certain devices which can be used by multiple teams, such as printers, storage devices, machines, CPU, RAM. ಇದನ್ನೆಲ್ಲನೂ you can bring them in common pool, and common pool in that we can allocate. So I'm having a very large data center. So from the data center I have a lot of computing resources. So based on how it is being used, I can also do planning. For example, 9 to 5 for this team, give them so many resources, so many CPU, so many RAM, so much of RAM. Between 6 to 10, you give these resources, you allocate the same resources to team B. So either we can plan it, okay, based on time also. So as a result, utilization becomes more. Utilization becomes more for the existing hardware. So idle agi iralla hardware and resources. Provisioning ಮಾಡಕ್ಕೆ it takes 6 to 8 weeks if you want to install in some 5,000 machines operating systems and configuration of other softwares. Physically it takes 6 to 8 weeks, whereas if you are having a software like a VMware, you can do the same work within 1 day. So as a result ಏನಾಗುತ್ತೆ, number of people required to do that work reduce. There are cost savings for the organization. ಈಗ 5,000 ಮಿಷಿನ್ಸು ಇದರಲ್ಲೆಲ್ಲ ಅವರು ಏನು ಬ್ರೌಸ್ ಮಾಡ್ತಾ ಇರ್ತಾರೆ, ಏನೇನು ಡೇಟಾ ಇಟ್ಕೊಂಡಿರ್ತಾರೆ, ಯಾರು ಹ್ಯಾಕ್ ಮಾಡ್ತಾರೆ, ಅದನ್ನು ಮಾಡಬೇಕಂದ್ರೆ ಯು ಹ್ಯಾವ್ ಟು ಕಂಡಕ್ಟ್ ಎ ಆಡಿಟ್. ಸೊ ಇಟ್ ಟೇಕ್ಸ್ ಲಾಟ್ ಆಫ್ ಟೈಮ್. ವೇರಾಸ್ ಇದರಲ್ಲಿ VMwareಲ್ಲಿ ಯು ಕ್ಯಾನ್ ಗೆಟ್ ಆಲ್ ದ ಲಾಗ್, ಯಾರ್ಯಾರು ಯಾವ ಏರಿಯಾದಿಂದ ಏನೇನು ಬ್ರೌಸ್ ಮಾಡಿದ್ರು, ಯಾವ್ಯಾವ ಅಪ್ಲಿಕೇಶನ್ಸ್ನ ಆಕ್ಸೆಸ್ ಮಾಡಿದ್ರು, ಎಷ್ಟೊತ್ತು ಆಕ್ಸೆಸ್ ಮಾಡಿದ್ರು, all this type of information can be done with the help of your virtualization platform. So these are the cost benefit things which are there. So especially software companies, they use virtualization for development, they use it for testing, they use it for training. Okay, software companies ಅಲ್ಲಿ awareness about virtualization is more, whereas other enterprises like manufacturing ಇರ್ಬೋದು, ಫೈನಾನ್ಸ್ ಇರ್ಬೋದು, ಇಂಥದ್ರಲ್ಲೆಲ್ಲ ವರ್ಚುಲೈಸೇಷನ್ ಬಗ್ಗೆ ಅವೇರ್ನೆಸ್ಸು ಕಡಿಮೆ ಇದೆ. ಸೊ ಇಟ್ ಈಸ್ ಇನ್ಕ್ರೀಸಿಂಗ್ ಡೇ ಬೈ ಡೇ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಎಜುಕೇಷನ್, ಈಗ ಲಾಕ್ಡೌನಲ್ಲಿ ಪ್ರತಿಯೊಂದು ಸ್ಟೂಡೆಂಟ್ಗೂ you can create a virtual environment in which they can work. ಬೇರೆ 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 ಕಾಲೇಜಸ್ಗೆ ಒಂದೇ ಕಂಟೆಂಟ್ ತಗೊಂಡು ಒಂದೇ ಡಿಗ್ರಿ ಕಂಟೆಂಟ್ ಫಾರ್ BCA. One lecturer can do training for a number of students, number of colleges. ಪ್ರತಿಯೊಂದು ಕಾಲೇಜ್ಗೂ ಒಬ್ಬೊಬ್ಬನೇ ಲೆಕ್ಚರರ್ ಹಾಕೋದಕ್ಕಿಂತ ಒಂದೇ ಲೆಕ್ಚರರ್ ಕ್ಯಾನ್ ಆಲ್ಸೋ ಅಡ್ರೆಸ್ ಟು ಮಲ್ಟಿಪಲ್ colleges or the same content, whatever the content that lecturer had prepared, ಪ್ರತಿಯೊಂದು ಕಾಲೇಜ್ಗೂ ಸಪ್ರೇಟ್ ಕಂಟೆಂಟ್ ಪ್ರಿಪೇರ್ ಮಾಡ್ಕೊಳ್ತಾರೆ. So the same content can be accessed by all the colleges with the help of virtualization. ಕೆಲವೊಂದು ಕಾಲೇಜು ಬೆಳಗ್ಗೆ ವರ್ಕ್ ಮಾಡುತ್ತವೆ, ಕೆಲವೊಂದು ಕಾಲೇಜು ಈವ್ನಿಂಗ್ ವರ್ಕ್ ಆಗುತ್ತೆ. ಸೊ ಇದು ಮಾಡೋದ್ರಿಂದ ಏನೋ ಈವನ್ ಲಾರ್ಜ್ ಯೂನಿವರ್ಸಿಟೀಸ್ ಲೈಕ್ IITs, ಹಾರ್ವರ್ಡ್ ಯೂನಿವರ್ಸಿಟಿ, ಪ್ರಿನ್ಸ್ಟನ್ ಯೂನಿವರ್ಸಿಟಿ, ಇಂಥ ದೊಡ್ಡ ದೊಡ್ಡ ಸಂಸ್ಥೆಗಳು ಕೂಡ now they can spread out to the entire globe. People are having different time zones, so you can get more admissions to your courses. You can get more admission to your courses. You can run more courses now. So as a result, ಈ ವರ್ಷದಿಂದ ಏನು ಮಾಡ್ತಿದ್ದಾರಂತೆ, so that is the news that you are graduating in BCA, no? Now they will make it available that you can graduate in 2 subjects. One is you are attending in classroom, another one you are attending through distance education. Suppose you want to specialize in 2 things. You wanted to do BCA and you also wanted to do something in foreign languages or painting or in security, IT security. ಯಾವುದೋ ಒಂದು ಸ್ಪೆಷಲೈಸ್ ಮಾಡಬೇಕು ಅಂತಿದ್ರೆ you can do and you can get 2 certifications from this year onwards, because ಇವಾಗ this that I think I read it just yesterday. Now you can get 2 certificates for your bachelor's degree and both of them are recognized. You can do 2 courses at the same time. So education kuda a lot of applications are there for this virtualization. Okay, this was what we used to have earlier, in which a hardware was there, on that an OS was there, on that different applications was there. ಅದರಿಂದ ನೆಕ್ಸ್ಟ್ ಇನ್ನೊಂದು ಏನು ಹೆಲ್ಪ್ ಆಯಿತು ಅಂದರೆ, ಫಿಸಿಕಲಿ ಐ ಕ್ಯಾನ್ ಕ್ರಿಯೇಟ್ ಪಾರ್ಟಿಷನ್ಸ್. ನನ್ನ ಹತ್ರ 500 GB ಹಾರ್ಡ್ ಡಿಸ್ಕ್ ಇತ್ತು ಅಂದರೆ ಐ ಕ್ರಿಯೇಟ್ ಎ ಪಾರ್ಟಿಷನ್. 250 GB ಕ್ರಿಯೇಟ್ ಮಾಡಿಬಿಡ್ತೀನಿ. ಒಂದು 250 GB ಒಂದು ವಿಂಡೋಸ್ ಹಾಕೋತೀನಿ, ಇನ್ನೊಂದರಲ್ಲಿ ಲಿನಕ್ಸ್ ಹಾಕೋತೀನಿ. ಸೊ ದಟ್ ವಾಸ್ ವಾಟ್ ಫಿಸಿಕಲಿ ಪಾರ್ಟಿಷನ್ ಮಾಡ್ತಿದ್ವಿ ಮುಂಚೆ. ಸೊ ವಿಂಡೋಸ್ used to think I have only 250 GB for my machine. Linux used to think I am having 256 GB for my machine. Okay, this was the earlier thing. Ivaga, what has happened? You will install what is called as an hypervisor or a virtual machine on your hardware. Hardware need not be one machine, it could be a chain of machines connected through cluster. ಅದರ ಮೇಲೆ ಒಂದು hypervisor ಹಾಕಿ we create virtual boxes. On that, each of the virtual boxes you allocate some resources from the common pool of CPU, RAM, hard disk, network. You can allocate separate RAM, separate CPU, separate hard disk for each of these virtual boxes. Each of these virtual boxes you can have separate operating system, and you can have various applications over those operating systems, and you can make these virtual boxes accessible by people from outside, from remote locations, by connecting it to internet. Now, in virtualization, there are multiple types of virtualization. You are all aware about Android emulator if you are learning Android programming. You know about a BlueStacks emulator on which you can run Android applications on Windows platform. These emulators, again, they require 62-bit operating system to be installed for runtime. ಅದಲ್ಲದೆ we spoke about full virtualization and para virtualization. Full virtualization ಅಂದರೆ bare machine virtualization. Para virtualization only, I will have at least one operating system upon which I am installing the virtual machine. We can virtualize the OS, we can virtualize the applications. Applications also can be virtualized. ಇದಲ್ಲದೆ where all virtualization can happen? In our infrastructure as a service. In our infrastructure as a service, people who are providing cloud services as infrastructure as a service, ಅವರಲ್ಲಿ servers, CPUs, okay, 64-bit operating system or a CISC operated CISC machine or a RISC machine. So you can specify my application will run on a RISC machine. Mostly banks applications will run on a RISC machine. So ನಮಗೆ RISC machines ಬೇಕು ಅಂದರೆ the data center can allocate RISC machines for them. Storage can be virtualized. Networks can be virtualized. VLANs ಮಾಡ್ಬೋದು. VLANs ಕ್ರಿಯೇಟ್ ಮಾಡಿ ಬ್ಯಾಂಕ್ ಬೆಂಗಳೂರಲ್ಲಿ ಡಿಫ್ರೆಂಟ್ ಬ್ರಾಂಚಸ್ಗೆ ಒಂದೊಂದು ನೆಟ್ವರ್ಕ್ ಹಾಕ್ಕೊಡ್ಬೋದು ವರ್ಚುವಲಿ. ಆ್ಯಂಡ್ ಆ ವರ್ಚುವಲ್ ನೆಟ್ವರ್ಕ್ಸಲ್ಲಿ ಯಾರಾದರೂ ದ ಮ್ಯಾನೇಜರ್ಸ್ ಇಫ್ ದೇ ವಾಂಟ್ ಟು ಕಮ್ಯುನಿಕೇಟ್ ಟು ಅನದರ್ ಮ್ಯಾನೇಜರ್ಸ್ ಅವ್ರಿಗೇನೆ ಒಂದು ಸಪ್ರೇಟ್ ನೆಟ್ವರ್ಕ್ನ ಕ್ರಿಯೇಟ್ ಮಾಡ್ಕೊಳ್ಬೋದು. ಸೊ ಯು ಕ್ಯಾನ್ create various virtualized network environment, virtualized storage environment, and virtualized hardware server environment. Okay, so now it is 12:30, 1 hour. So I'll give you 10 minutes break for you. 12:30, 12:40 ಅಷ್ಟೊತ್ತಿಗೆ ಬನ್ನಿ. Okay, have your water break. 12:40 will continue.
The board for today's presentation. My name's Darryl Whittaker. We're going to explore some of the basic concepts of virtualization. If you're not familiar with VMware products or virtualization concepts, you should find this video. We'll take you back to the basics where we'll discover what a virtual machine is. We'll explore some of the benefits of virtual machines. We'll also discuss how we...
Is the audio Okay for you?
Run and manage virtual machines through the use of ESXi hosts and Virtual Center. So let's start by discussing what a virtual machine is. The traditional physical architecture model that we used to follow probably 10 or so years ago was that we installed an operating system, a server operating system, onto a physical x86-bit server. And within that operating system, we installed whatever applications that we wanted to run. So maybe an email service, maybe a web server, whatever application it is, a database server or something like that. So what we used to do was, in order to isolate these apps from each other, for example, if you put your database server, your email server, and your web server all on that same physical server, if you had to do email maintenance, you'd now be affecting your web server and your database server. So we achieved isolation by buying more hardware and installing separate operating systems and putting these apps into separate hardware solutions, right? Now, this was great, except it caused us to purchase lots of hardware. It helped us achieve the isolation between these apps and improve services, but of course, it was not a very cost-effective way of implementing isolation. So virtualization, or virtual infrastructure, takes that underlying physical server, and keep in mind that the hardware that we buy in these servers today are enormously more powerful than what we had 10 years ago, even 6 months ago for that matter. But instead of installing a thick operating system and an app in a one-to-one relationship, we introduced this concept of virtualization. And of course, virtualization is not a new concept. It's been around for some 40-something years, where IBM pioneered this concept of being able to share physical resources. So we install this thing called a VMware hypervisor. You may have heard of this called VMware vSphere. Other terms that we use, of course, is ESXi. But this is the operating system that we install onto the server that allows us to achieve virtualization. So what do I mean by that? That operating system has a job, and that job is to effectively, as an operating system, share the underlying physical resources, so what we call the core 4 resources, which I'll get to here in a second. So then we build these things called a virtual machine. Now, where things change compared to the physical model is, instead of installing an operating system and an app, now we create a virtual machine. And a virtual machine is kind of like a bubble, if you will, where we can build multiple virtual machines and share the underlying physical resources, because again, our hardware has gone beyond what we typically consume in a server operating system, which means that we can share the underlying physical resource to a certain extent and build multiple virtual machines. Now, each one of these virtual machines is isolated from each other, and you can install an operating system and an app in each one of these virtual machines, and we can have multiple VMs on this underlying physical platform. And of course, we still can leverage things like centralized storage to achieve availability, like iSCSI, NFS, fiber channel, virtual volumes, vSAN capabilities, which I'll get into in our later presentations when I get to storage. But the idea, of course, is that we can share these underlying physical resources because we have larger capacities available. We can even go so far as overcommitting the resources, because if you think about it, not all these virtual machines require these resources at the same time. Now, we've got tools to help you manage and implement that safely. Again, we'll get into that in our next webinar or next video recording. So the traditional model was to take a physical install, the operating system, install the application, and of course it had exclusive access to the hardware in the physical server. In our virtual architecture, we install ESXi, and ESXi is a very thin operating system designed to share the underlying physical resources in the box. Now, with more architecture and more CPU and compute resources available in this platform, we have the ability to create these things called a virtual machine. And think of a virtual machine, like I said, a bubble or a software construct that isolates each operating system from each other. Now, of course, the operating system still needs to behave and gain access to CPU, memory, network, and disk space in order to obviously host the operating system, but also run the application. So the ESXi hypervisor gives us the ability to create these multiple VMs and share the underlying physical resource and overcommit. And the ESX hypervisor really, its primary role is to share the underlying hardware with these various machines that you might choose to run on top of their server platform.
Okay, so in this video till now, you have heard about some VMware operating system. Okay, VMware OS, it is called ESXi, or also called vSphere. Okay, so on the bare machine, instead of installing Windows or Linux, you install this thing on the bare machine. It is programmed to be installed on a bare machine, just like any other operating system. On these, you will create virtual machine boxes. There are 53 people, so each of you will get 53. Each of the 53 will get an independent box, independent computer. Each of these independent computers, you will have your own desired operating system. Whether you want Macintosh, you want Windows, you want Linux, each of you will have your own desired operating system. And on top of it, an application will be hosted. This application which we are hosting, it could be a common application also. For example, there is one learning education portal which you want to access for cloud computing. Now each one of you are having a different operating system. You are having a Mac OS, someone else is having a Linux OS, someone is having a Windows OS, like that. But all of you are enabled to access this portal, which may be accessed through internet. All these 53 virtual boxes will be enabled to access internet. So once you are enabled to access internet, you are as good as working. You are having your own Mac machine. If you want to have a Mac machine, you will have to spend some 1.5 lakhs, isn't it? You will have to spend about 1.5 lakhs. Now with this VMware vSphere type of operating system, you can create a Mac machine, which is not 1.5 lakhs. Okay, so you will be doing other applications also on that Mac machine virtual box. So you can give different virtual box. Somebody wants a Windows machine, Mac machine, and a Linux machine. So you give him 3 boxes. Okay, so that can be done. So VMware has got a solution called ESXi or vSphere, And IBM has got what is known as Power VM. IBM solutions is known as a Power VM solution. Okay, so this you may get one or two questions in the you should know for general knowledge purpose. VMware's OS is ESXi or vSphere. I try to install, actually in your lab you are supposed to install vSphere. To install that, again it has to, the configuration of the hardware is very important, the RAM and also the architecture of the motherboard. We'll see in your lab. If we get a suitable machine, then we will be installing the vSphere. So we will be installing the vSphere. Let me show you vSphere. Reload it. Yeah, I think I have removed it because the software was there. We can we can download a trial from the net and we can install that. Advantage is, so we can install that vSphere on a bare machine. You can install it on a bare machine, and on that you can create virtual boxes. You can make those virtual boxes connect to internet. Okay, these things can be done. Okay, I'll continue with this video. Okay. Now you should be able to understand what language is talking and what is ESXi, what is vSphere, all that. Okay.
So why use a virtual machine? Well, if you think about that one-to-one relationship, made it difficult to move operating systems and apps from one hardware server platform to another hardware server platform. So it didn't provide transportability, or probably better said, availability. So it was more physically binding. It was difficult to manage, required physical maintenance anytime we needed that operating system or application. Sometime a maintenance or patch or reboot, we had to take down the entire system. Of course, go through a reboot, which leads to downtime. Even downtime caused by hardware failures obviously was a big inconvenience, and availability for modern day businesses is very important. So hardware traditionally had its limitations. With a virtual machine, when we build a virtual machine, each VM is essentially in its own bubble, I should say, and we can encapsulate the virtual machine into a set of files. And each virtual machine is independent from the underlying physical hardware. So it's not binding to the physical properties and the physical hardware platform. It actually has a set of drivers designed to interact with the ESXi kernel more efficiently, but it's independent from the underlying physical platform. Which means if this virtual machine is embedded into a set of files and we put those sets of files into a central location, we then achieve portability. Because if we have multiple ESX servers and they're the same version, of course, we could power on and run that virtual machine on another host, supporting that capability. So through the ability to isolate these VMs from each other and insulate from hardware changes, we then gain the ability to not only run a virtual machine and share the underlying hardware, but achieve some of the transportability that we need in order to achieve availability overall. And again, I'll get to that in our next video. But virtualization also gives us the ability to support legacy-based applications. Think about that old Windows 2000 server that you have running an old version of SQL database that you're struggling to maintain. And if that server falls over, obviously you might be in some serious hot water, and trying to be able to find hardware. If we could take that and put it into a virtual machine, obviously we're no longer bound to the underlying hardware. Therefore, we solve the hardware problem. It's probably a good idea to go out and work on the software problem as well. But it does allow us to support legacy applications in this model. It also allows us to consolidate and reduce the quantities of servers that we buy these days because of the additional resources that we have available in these modern x86-bit / 64-bit architectures. So to describe the ESX kernel of a hypervisor, the hypervisor's job really is primarily sharing these underlying Core 4 resources. And I think I mentioned these Core 4 resources earlier, so CPU, memory, network, and disk. So the hypervisor's job is to share these resources. In a one-to-one mapping, everything's pretty simple, right? The operating system and application has exclusive access to the entire hardware. So when we build these virtual machines, we can build a VM that has one CPU. We can build another VM that has two CPUs, another VM that has four CPUs. And we might only have four CPUs available in the physical server, but again, our operating systems may not be using all this capacity at the same time, and this is how we start to achieve consolidation, certainly from a CPU standpoint. So we can build these VMs with different virtual configurations, and of course those CPUs map to an underlying virtual CPUs map to an underlying physical CPU in order to do whatever computational value it needs to run. That doesn't change, right? Still needs the physical processor. If we take that a step further, we can also share the amount of memory in a physical server. So we can have a virtual machine that has 1 gig of memory. We can have another VM with 2 gig of memory, another one with 8 gig of memory. And again, they may not all require that total capacity of memory all the time. If they did, they'd be running at 100% memory utilization, and obviously they wouldn't be performing very well. But so quite often these operating systems are not using what they're actually given. So with that in mind, we can consolidate memory, and we might only have, say, 10 gig in this server, and we've given away 11 gig worth of virtual memory. The ESX kernel manages that sharing of that underlying physical memory, and that's its job in resource management. Take it a step further in our Core 4 resources into networking. Now, our virtual machines can have a virtual network adapter. That virtual network adapter connects to other virtual machines through what we call a virtual switch. And then by the nature of adding a physical adapter into that virtual switch, we can then put packets on the wire. So this is think of it as a standard layer 2 store and forward packet switching concept. Standard layer 2 switch. And again, I'll get into the networking side in a future video here shortly. And we take that a step further. We have the ability to, instead of having dedicated storage in a physical architecture, we can connect to centralized storage and store virtual machines in a central location. Again, giving the ability to register a VM on another host and run that virtual machine from another host in a compatible ESX architecture. So virtual machines are a software computer, not a hardware computer. and they're consumers of resources, just like an operating system traditionally would. You still need CPU, memory, disk, network, video card, etc., to gain access and to run the services that the operating system and application needs, right? That hasn't changed. What has changed, of course, is that we're sharing the underlying physical resources and we can overcommit, and we map these to our virtual machines. So VMs are basically containers that run almost any operating system and application. They offer a segregation between virtual machines. So every virtual machine effectively exists in a bubble isolated from the other virtual machines. And the way this virtual machine communicates with other VMs is in the traditional sense via networking, or is otherwise permitted through SDK access in the kernel. But each virtual machine has its own resources. We map quantities of hardware into the virtual machine and what we call virtual hardware, and that virtual hardware maps to the underlying physical hardware to do what it needs to do. VMs generally do not realize that they're virtualized. So the operating system that we install typically has no awareness that it's virtualized. We will install a set of tools or drivers inside our operating system to work more efficiently with the ESXi host. However, the operating system has no idea it's virtualized. It just thinks it's a traditional operating system or a computer and runs as it normally would. Now, in order to separate each virtual machine into its own bubble, each virtual machine is isolated into a folder all by itself. And every virtual machine has its own unique set of disks and files that make up the virtual machine. So think
Okay, are you able to hear the audio and are you able to see the video? Are you able to see the video? Okay, fine. Just a minute. I wanted to show you, as he was saying, see, what you- So each of these virtual boxes which we have installed in this VMware, it appears like a file. Yeah, good afternoon to the tell me. Just a minute, I can't hear your voice, it's breaking. Mm, yeah, little bit. So, uh, correct. You want the profile and commercial, is it? Okay, that I'll send it. I have sent it many times to your people. The same thing, it doesn't change. There will be, my profile will be there in some 10 locations in your company. I'll send it again. I'll send it. Okay. Now you see each of these OSs which I have installed, I'll go into that. Okay. Now each of these, so whenever I have uh, used it, whenever I have used it, okay, whenever I have used it, so it behaves like a file. It behaves like a file which has been uh, communicated to its virtual CPU. Okay, and from there it is connected to the each of this. These are all, they don't behave like a machine itself. They don't behave like a virtual machine. They all behave like a file. So that is what he is mentioning. Okay.
And the way this virtual machine communicates with other VMs is in the traditional sense via networking or is otherwise permitted through SDK access in the kernel. But each virtual machine has its own resources. We map quantities of hardware into the virtual machine and what we call virtual hardware, and that virtual hardware maps to the underlying physical hardware to do what it needs to do. VMs generally do not realize that they're virtualized. So the operating system that we install typically has no awareness that it's virtualized. We will install a set of tools or drivers inside our operating system to work more efficiently with the ESXi host. However, the operating system has no idea it's virtualized. It just thinks it's a traditional operating system or a computer and runs as it normally would. Now, In order to separate each virtual machine into its own bubble, each virtual machine is isolated into a folder all by itself. And every virtual machine has its own unique set of disks and files that make up the virtual machine. So think of this as folder storage in Internet Explorer, where you create VM number one and all the associated files with virtual machine number one get stored in folder number one.
So this is precisely what I was saying. So each of these virtual machines, they get stored in separate folders. They have been stored in separate folders.
Whatever you've called your virtual machine. And again, this could be shared storage solutions of various different flavors. If you're interested, some of the files that make up a virtual machine, at a high level, I won't delve too deeply into them, but we have a configuration file. And of course, you can imagine what that thing does. It tells us how much CPU, memory, network adapters the virtual machine has, as an example. Every virtual machine has its own BIOS, copy of the Phoenix BIOS. And that has a .nvram extension. So if you called your virtual machine Fred or Fred01, you would have a Fred01.nvram for this particular virtual machine. You'd have a Fred.0 or Fred01.vmx file for this virtual machine stored in that VM's folder. We also have log files. We have, if we're using virtual machine templates, a VMTX file. Our virtual hard drives have what we call a descriptor file and a data file. The descriptor file basically describes the properties of the virtual disk where data is stored. So think of this as if you installed an operating system onto a laptop, it would pick up the hard drive that's on your laptop and of course read the block structure and formatting structure of that disk, and then of course format that operating system or format the file system, and of course implement the operating system in that file system, etc. So the descriptor file describes the virtual disk, and then the data file is actually the large disk. So if you created for example, a 20 gig C drive, the 20 gig file would be fred01-flat.vmdk. This is the one.
Okay, so with memory, these are the various VMDKs which has been created for Ubuntu. So likewise, you will have it for CentOS, which I had installed, Windows XP also. Windows XP is also stored in this way. Okay. Yes.
And it'll take up all the disk space. We have other files that are associated with the VMs as well, like if we create snapshots, if we're using change data tracking, other functionality, which again I won't dig into in today's session. So how do we run virtual machines? We talked about ESXi, right? VMware ESXi. So ESXi is the hypervisor that installs onto that physical server and allows us to create these virtual machines. It also allows us to share the underlying physical resources in these VMs. Now, it's a very thin operating system. It's a bare metal hypervisor. This operating system is small enough that we can actually load it over a network and using a network boot and load it directly into memory, so we don't actually require local hard disk in that server. ESX server installs directly on that physical server, is in control of all of the physical resources in that underlying operating system and physical server, I should say, and shares them with these various virtual machines. So those core form resources, CPU, memory, network, and disk, and allows our virtual machines to be run at near native performance. So there's not a big overhead for this hypervisor, unlike any other hosted hypervisor solutions. ESXi6 allows up to 480 physical CPUs to be shared in a host. You can have 12 terabyte of RAM and up to 2048 virtual machines on a physical server.
So, see, this is the capacity of the VMware operating system. Okay, when you are using it on a bare metal, you can have that bare metal which is installed. It is installed in a cluster of servers. It can utilize 480 CPUs. 480 CPUs per host machine. Okay, it can take 400. So the host machine should be bigger than this, isn't it? It should be bigger than this. The largest machine which can have this should be more than, it should be able to host 480 CPUs or more than 400 CPUs, like the tower servers. Okay, 400 or even the blade servers, the connectivities of blade servers which we have seen. So they will have 480 CPUs. So if you are having a blade server connectivity, let's say there are 8 CPUs in each blade. So some 60 blades servers are connected in a cluster. 60 blade servers are connected in a cluster, and that is the size of the hardware. On this you will host this ESXi. On this you will host this ESXi. So 480 CPUs are there. It can have 12 terabytes of RAM. So who uses this? Who requires this type of systems? Indian Railways will require, Reliance Jio will require, Amazon will require, airlines booking will require this type of a system. Okay, or even somebody who wants to access government websites. Let's say you want to access your RTO, Regional Transport Officer website. Now they have made a centralized Regional Transport Officer website. All the documents are same throughout India now. Okay, so if people want to access this site from everywhere, remember, think about the number of people who will be trying to access at a point of time. They will be sharing lot of resources on this, and if this application, RTO application, which is hosted on some server, that server should have some capacities like this, like 480 CPUs per host, 12 terabyte of RAM. It can deploy 2048 virtual machines per host. Okay, so you can increase the number of hosts also, and number of virtual machines also can be done. So it is done for, like bulldozers. These are all like bulldozers or JCB machines. So these are all for heavy duty IT computing.
Now, to me, that begs a question logically, is that if I have 2,000 VMs on this physical server and I lose that host, or that ESXi host or physical box, obviously I've lost 2,000 virtual machines. So that's when we get into an availability discussion, which I'll expand on again in the next video. So the ESXi architecture, this kernel installs onto this physical platform, and of course we have a VMware management framework. So we have the core shell and a console that is our shell. The operating system, it's not like logging into a Windows box. It's a very thin operating system. It's not really designed for you to log in and have all these elaborate services and functionality running. It's designed to be that core hypervisor that shares resources and gives us the ability to create virtual machines. It supports an agentless system for management, for our management tools to be able to connect in and manage this as a fabric, if you will. We have command line integration configuration support, so we can do things like diagnostics on that physical server if we have faults. We also have agentless hardware monitoring using the common information model, and that's extensible and integrates with other third-party solutions for integration. And of course, the core concept, which is providing and building virtual machines and sharing the underlying physical resources amongst those virtual machines. So how do we manage VMs? Now, we have a client.
Okay, just some brief description about it was a movie about VMware vSphere. Now, VMware vSphere is the OS for a bare machine for hosting a virtual machine environment, virtualization environment. Now, this software, VMware vSphere, it consists of a very thin software which can be hosted on a bare machine. That thin software is called the kernel. So every software has got a kernel. Windows has got a kernel. Every OS, Linux has got a kernel. What is this kernel? Kernel is the engine of the software. Okay. So this kernel, there has to be a kernel. So this kernel is very thin. Along with that, they have some management software, configure software, because you as a administrator, server administrator, IT administrator, or a data center administrator, you need certain softwares for provisioning. You need softwares to see which applications are running. You need softwares to deploy the resources, make changes with the resources. You need a software to create your own MIS reports for documentation purposes. Okay. You require these reports for maintenance. Okay. So there are all the additional softwares which are added along with this. Now, this type of softwares are nothing new. They are available in each and every operating system. In Windows Server, suppose if you go and try to learn Windows Server administration, you will come across what is the Windows kernel. That is what you will be installing within one bare machine. They will give you a server. They will give you a bare server. On the bare server, you will host Windows Server software. You will install it. Then you will have to configure how many users will have to access this server, what all this server is supposed to do. Is it supposed to have only MS Office or Adobe, or should it enable internet also? Should it install some web enabled software? Okay, you are designing some HTML pages. Do you want to host it on a web server? So the web server has to be hosted onto this machine. So you will learn all this if you learn Windows Server administrations. Likewise, there is Linux Server administration. There also you have the Linux kernel, which you can download from the internet, or if you are having it in a CD or a DVD, go and install it on a bare machine. You will learn how to install Linux. On this Linux, when you want to configure the users and all that, there are various management tools on the servers which helps you to configure the users, configure the rights of the users. check out the status of the clients from the server. Okay, you are having a Linux server and you are making it connected to various clients. So from the server you should be able to monitor the clients. Okay, all that can be done in Linux server also. Similar like that you can do with VMware VSXi. The only difference between those operating systems and VMware VSXi is VMware VSXi or vSphere, the new name of the software. This is used to create a computerized, a computer, uh, a software computer. It's not a hardware computer. VMware VSXi helps you to create a software computer, number of software computers. On those software computers, you can install various operating systems and applications. You can monitor the writes, monitor the performance of the users. Okay. Now the history. Now when did this thing called virtualization start? IBM had got a mainframe computer, very large mainframe computer called CS40. Now these mainframe computers even today are used in banks, insurance companies, airline companies, utility like electricity, telecom, water, such companies in the United States and Europe. They are still being used. Okay, these are all heavy duty machines. Mainframe computers are heavy duty machines. Now organizations have purchased these heavy duty machines and they were working on it. They will work from 9 to 6. Okay, so during those times computer traffic is more. After 6 o'clock they all go home, so the traffic on those machines is very less. Maybe some maintenance, some backup, such type of work may be there, but computing will be very less. So this gave an idea to IBM, why should we not develop something in which when these machines are not being, if they belong to the same company, and if the company is there in US in three zones, three time zones, okay, once the first zone people log out of the computer, why can't this resources of this machine be used by the people of the second zone or the third zone? So this is where it helped them to come out with this virtualization technology, and that machine they developed the virtualization was called CS40. Okay, so mainframe virtualization happened, which led to over a period of time to desktop virtualization, in which uh, we started having Intel architecture computers. Okay, now the mainframe computer is not Intel architecture computer. The mainframe computers, IBM mainframe computers, they are not Intel architecture computers. What are the Intel architecture computers? The 286, 386, 486, 586, all these machines which are from Intel, they have a different architecture. And they are all used for business computing. Like people use it in commercial organizations. And people are comfortable using those Intel architecture machines. Now in this Intel architecture machine also, this virtualization was adapted. From the mainframe computers, it went to Intel architecture computer virtualizations. In that, the need was there for the servers. More than the clients, it was required for the servers. Because servers, people are spending a lot of money on servers, but server utilization was not happening optimally. So virtualization helped to pool the resources which were not used and allocate it to some people who require those type of resources. And now it has this is very much required in cloud, because cloud is nothing but again data centers. Data centers have cluster of computers. This cluster of computers behave like one single computer. On this, you not everybody will be taking the entire cluster for his work. Even if he takes one entire cluster for his work, he will not be working on it always, which is unnecessary money spending. So cloud computing said, okay, we will offer this to you on rentals instead of you spending money as a fixed cost. We will give it to you as a rental. You use it. When you are not using your CPU, RAM, and all that, I will make these CPU, RAM, storage, and all that to be used by someone else, and I charge him. So the cost of computing drastically came down because of this virtualization. Okay, then let me close this. Okay, on time sharing basis also, you can. Okay, IBM's virtualization is called Power VM, whereas VM, the virtualization solution from VMware is ESXi, VMware ESXi, or VMware vSphere, and also VMware Workstation Pro. Workstation Pro is for the client, on the client side. What we are using is on the client side. It can also be installed on the server as a VMware ESXi, and you can configure the clients. So here we are talking about again how it was used for the next IBM thing. So this also, you have the basic Intel architecture, which is the motherboard. On top of it, you have a virtualization layer such as ESXi. On top of it, you have your desired OS on which you will have some application, and each of these boxes are separate. Impact of virtualization is cost and manageability. Costs have reduced. If you are supposed to buy 5,000 systems, now you can buy just maybe some 50 systems. So 5,000 to 50 is a cost saving. The cost of having a large network is also not there. The cost of maintaining people is also not there. Large number of people for troubleshooting. Manageability, earlier, if some problem had happened in some machine, so they have to go with some sensors to find out where the network is down, okay, where the machine is down. So it used to take so much time, and when they are trying to do some maintenance, the machines used to be down. So all the people will be jobless during that point of time. Now with this virtualization, the time taken to do maintenance and time taken to monitoring is just a fraction of the time taken for physical auditing and physical maintenance. So the manageability is better. The manageability is better. So infrastructure virtualization is there. Just now, what are the benefits now? So virtualization is also evolving. So in this evolvement of virtualization, we are able to have virtualization of infrastructures, virtualization of application, and also the platforms. Platforms are there, applications are there, and we also have now what is called as a desktop virtualization. In desktop virtualization, especially in companies like Infosys, Hindustan Unilever, Godrej, such companies, each of the executive is given a sort of a interface, Windows interface, okay, your Windows operating system interface, in which you are supposed to use some set of software. Now this software is not installed in your computer. It is installed in the cloud. It is installed in the cloud, and you are given access to use those softwares. So you will see that you will log into that your machine with a login ID and password, and you will start using this application. Suppose you go to Singapore for a meeting and you want to access your machine. You have not carried the machine. You don't have to carry your laptop also. Okay, you have gone to Singapore. So from the Singapore, you connect to your company cloud with your login ID and password, and you will see the same interface, same windows what you have in your Bangalore office. The same thing will be appearable to you in Singapore also. The same software, same look and feel, everything will be same. So this is what we call as a desktop virtualization. You will have something called a desktop virtualization. So infrastructure virtualization is you are virtualizing your CPU, storage, network, okay, data center. The entire thing is infrastructure virtualization. Cloud platforms such as your operating systems, your business platforms which you may be using. So that can be virtualized. Your applications, your softwares, okay, all this can be virtualized. In addition to that, your desktop, whatever you are using as a desktop on your laptop or mobile, whatever you are using, the entire look and feel also can be virtualized. So you will be working on your own system wherever you are working from. Okay, that is about desktop virtualization. So now, okay, fine. We have come to the first chapter is very small in this introduction to virtualization and cloud. It's a small one. So there are some questions which you can answer. These are the common shortcomings of physical infrastructures: asset management, tracking, utilization, security and compliance, provisioning, staff for administration, sizing, optimization. True or false? True, false, partial true, partial false. What is the answer? Shortcomings of physical infrastructure. Can you hear my voice? Okay. Hello? Okay. The shortcomings of a physical infrastructure. Physical infrastructure is you are having computers, servers, local area network, routers, firewalls, everything you are having. They have some shortcomings. What are the shortcomings? They say that asset management of that, you have to keep upgrading your hardware, you have to keep upgrading your software. So it is true. Okay, somebody says it is true. The dash code is logically equivalent to a hardware processor. Hardware processor means it's a computer. Now you are having this vlog code. Okay. Okay, your VHDL code. Okay, the entire hardware is converted into something like a called as a VHDL code. This VHDL code is the equivalent of a hardware. Okay, the VHDL code, sorry, the VHDL code is logically equivalent to a hardware processor. Okay, what is this VHDL code? It is given as something as very high speed integrated circuit. Okay, very high speed integrated circuit, hardware description language. Hardware description language. HDL stands for hardware description language. Very high speed integrated circuit code, but it's all called VHDL code. It is logically equivalent to a hardware processor. A dash storage can be converted into an ISO 9000 software image. What do we mean by this? Okay, you have this ISO images. If you want to install any OS, usually you will get it as an ISO software image. Okay. Even in the VMware, when you want to install some software, either you need to have a original CD-ROM drive, but which we may not have. So we usually get it as a ISO 9660 software image, ISO image, which you can download from the internet, 4 GB, 5 GB, 8 GB, like that. You get different softwares. These softwares you take it in a pen drive, okay, and then you upload it into your VMware. Okay, in this, we had a CD-ROM drive. A CD-ROM drive can also be transformed into a sort of a code, and this is called as an ISO 9660 image. Okay, native virtualization, para virtualization, all these types of virtualizations are classification of virtualization based on the extent of hardware emulation, based on the technology of the area being virtualized. A and B, none of the above. It's both, virtualization, like full virtualization and para virtualization, is based on hardware as well as the OS which we had used. We can do CPU virtualization, storage virtualization, application virtualization. Okay, so that's a technology. So for this answer, both A and B are the answer. Okay, the earliest pioneer company was IBM. Intel introduced Intel VTX and AMD produced AMD to support virtualization in hardware. Dash eliminates most of the inflexing duties inherent virtualization. Okay, the dash is responsible for allocating memory, CPU resources, and storage in each and every virtual machine. What is that which is responsible? That is called as the hypervisor or the software computer. The software computer is called as the hypervisor. It is responsible for allocating memory CPU. These are all simple things, and I think it's your lunch time now, is it? Okay, just 5 minutes more is there. So I do not know whether you people have been enabled for this module. Just check it out in your LMS. I have asked them to enable it today. If it is not there, then I have given you the link to the Google Drive to download from my repository. So there is a chapter called Introduction to Virtualization and Cloud. Go through that first chapter, you will be able to understand. Then those two PDF files which I have sent you, the first PDF file is about virtualization. You can go through that also, please. Okay. Any questions? Anybody? Participants? Anybody came now? 47.